Okay, so here for our third problem, we want to find the area of four figures. So we want to find the area of the square that we have here, ADQX and BQLE, and also the area of the parallelogram DCME, the area of the rectangle AELX, and the entire area of the irregular polygon that we have here, an irregular heptagon ADCMELX. Okay. So how do we do that? So the first thing that we need to do is we need to find the measurement of line segment XQ. Okay, so line segment XQ. So how do we find that? So we have our first clue here. XQ is the same. It has the same measurement as QL. So if they have the same measurement, XQ is the same as QL. So therefore, we can divide 12x plus 4 into 2. Okay, 12x plus 4 divided by 2, so that's going to be 6x plus 2. And there you go. We found the measurement for the side measurement XQ and side measurement AX. So our next step is going to be, we have to create a equation that will give us the value of x. So we can try to use the Pythagorean theorem. So that's going to be a squared plus b squared is equal to c squared. And since we know that xq is simply 6x plus 2, okay, so we can rewrite this equation as 2 times 6x plus 2 squared is equal to c squared, which is 10 square root of 2, which we need to square. Okay, so what's 6x plus 2 squared? So that's 36x squared plus 12x plus 12x, so that's going to be 24x, and then 2 times 2, that's going to be 4, and then times 2, okay, is equal to 10 square root of 2, okay, 10 square root of 2, okay, times 10 square root of 2 is simply 200, okay, that's 200, okay, so we have to distribute the value of 2 here for our equation. So that's 36 times 2, so that's going to be 72x squared, and then 24x times 2, that's going to be plus 48x, and 4 times 2, that's going to be plus 8 is equal to 200. And if we transpose that, so that's going to be 72x squared plus 48x, and then that's going to be minus 192 is equal to 0. And then we can divide these terms by their common multiple, which is 24. Okay, so the answer is going to be 3x squared plus 2x, so that we can solve it much faster. And then 192 divided by 24, so that's going to be minus 8 is equal to 0. And if you use the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the value of x, using the quadratic formula, the value of x is going to be 4/3 or negative 2. Okay, but we can't use negative 2 since there is no negative measurement for the sides. So the value of our x is 4/3. And therefore, we can now get the measurement of, of side xq. So side xq is 6x plus 2. So that's simply 4/3, okay? So that's simply 6 times 4 over 3 plus 2. So we cancel that one. We get a 2 here. So 2 times 4, that's 8 plus 2, so that's 10. So the measurement of side xq is simply 10, and therefore that's the measurement of all of the sides of XA, AD, and DQ for our square ADQX. So that means the area of square ADQX is 10 squared, so that's simply 10 squared, that's simply 100. So the area of the square ADQX is 100. And also, of course, DE LQ is also 100. And therefore, our rectangle here, which is the sum of the area of the two squares that we have, is 200 meters squared. Okay, So the perimeter, the area of the rectangle AELX is 200 meters squared, and the area of ADQX is 100 meters squared, and the area of DELQ is 100 meters squared also. Now we need to find the measure of the area of the parallelogram. So how do we find the measure of the area of the parallelogram? So the formula for the area for a parallelogram is A is equals to base times height. Now we know that the height, the value of our x is 4/3, right? We already solved for that. So it's here. So we substitute 4/3 for our height here. And then the value of our b is simply 6x plus 2, since they're congruent, right? So that's going to be 6x plus 2, so that's going to be, what's the value of that? So it's going to be 6x plus 2, we've already solved that, so that's going to be 10. Okay, so that's going to be 10. Okay, so the area of the parallelogram that we have here is actually 40/3 meters squared. Or if we divide 40 divided by 3, so that's in decimal, 13.33 meters squared. So this is the area of the parallelogram. Now if we want to know the area of the entire irregular polygon, the irregular heptagon that we have here, ADCMELX, the irregular heptagon, we just simply have to add 200, the 200 meters squared, the value for the area that we have for the rectangle. So that means the total area of the irregular heptagon that we have here is 213.33 meters squared. Okay, so this is the area of the irregular heptagon, or the irregular polygon that we have right there. Okay, so our next problem is going to be about a circle. So Rex wants to create a cylindrical shaped tower. So inside the tower is a floor pattern in the shape of a large square that has a diagonal of 54 meters. Now this 54 meters goes through the center of the circle and also is the diagonal of the square. So we want to find the circumference of the cross section, and of course the area. We want to find the area of the circle that we have here. So our main goal here is we want to find the radius. Okay, so to get the radius, so very easy. Since the 54 meter diagonal passes through the center, we just have to divide 54 by 2. So what's 54 divided by 2? That's 27. So 27 meters. That's our radius. Now, in order to solve for the circumference of the circle, so the area for a circle is pi r squared. Okay, so we just simply substitute 27 there, and then we have to square 27. So 27 squared is actually 729. Okay, and if you multiply that by pi, so the area of the circle of the cylindrical tower is 729 pi squared. Oh no, 729 pi meters squared. Okay, and if we want to translate that into a decimal, so 729 pi is, okay, into a decimal, so that's 2,200. So the exact area in decimal is 2,290.22 meters squared. So this is the area of the cross section of the cylindrical tower that we have here. Okay, so for our next problem, we want to find the measurement of the area of an ellipse. So the ellipse here is the one that's in the middle of the circle. So an ellipse is shaped like an oblong in a way. It's kind of shaped, it's shaped like the orbit around a given planet. So the orbit of different planets is shaped in an elliptical pattern, or an elliptical way. So here we have an ellipse, and it has two major parts. So the major axis is the one that's the bigger segment right here, so that's x plus 3 meters, and we also have a minor axis, so it's much smaller to the major axis. It's measured as x and x meters. So the formula for finding the area of an ellipse is pi. Okay, the area A is equal to pi pi AB, where A is your major axis and Y is your minor axis. Okay, but before we can solve for the area, we need to first find the value of x. So we're given here a clue. We have here a circle, and the circle has a radius of 25 meters. Now, the circle is composed of two parts. Line segment VC. So line segment VC measures x over 4 meters, and then line segment CE. Okay, line segment CE, so it's equal to the radius that measures x meters. So we simply have to add x over 4 plus x to get the value of r, which is 25, and therefore we can get the value of x. So x could be also equal to 4 over 4, so we can simply add that. So that's going to be x over 4 plus 4x over 4, so that's going to be 5x over 4 is equal to 25. And if we cross multiply that, that's going to be 5x is equal to 100, and therefore x is equal to 20. Okay. X is equal to 20. And therefore, we can find now the measurement of the minor and the major arcs, major axis. Okay, so the minor axis, x is just going to be 20. So A is going to be, so that's pi. So A is the major. Okay, so that's going to be 20 plus 3, so that's going to be 23. Okay, pi times 23, and the minor is simply x, so that's just 20. So 23 times 20, so that's 460. 460 pi. Okay, and if you want to transform that into a decimal, so that's going to be 1445. 1445.13. Okay, 0.13 meters squared. So this is the area for the ellipse. The area of the ellipse is 1145.13 meters squared, or 460 pi meters squared.